Hi, Mrs. Sparks.
Hey, Alec, how are you?
Good.
Good. What's up?
Nothing much.
Cool.
Just working.
I'm sorry?
Just working.
Yes, it is working. I'm glad. Can you see the study guide okay up there?
Yes, very well.
Okay, good. That's awesome. Um, I want to ask you something. Is there a difference between I'm gonna do two things and you tell me.
Yes, that is.
Mhm.
There's
Okay.
a that you can't see the study guide anymore.
All right. Now let me ask you this. You can see the study guide, right?
Yes, ma'am.
Okay. Is this bigger and better, or is there a
This
difference?
is smaller than the previous.
Okay. Is
That
that
yeah,
better?
that's a lot better.
Is it?
Yeah, that's a
Cool.
ton.
Okay. All right. Well, I'm experimenting. Thank you for letting me experiment with you.
Oh, no problem.
Do you want me to go through the study guide with you?
Uh, yes, ma'am. That'd probably be good.
Okay, cool. Hey, is Campbell, Evan, how are y'all? Good. I'm getting ready to start on the study guide. Page one. Campbell, I can barely hear you. So, what I'm going to do is do a problem. And can you hear Campbell okay, Alec?
Yes, ma'am.
Oh, wait, somebody was just talking. Who was that?
I don't know.
Okay. Because I
I
was
can
going to
hear.
say,
She sounds really quiet to me.
oh yeah, she does sound really quiet, but she's quiet anyway. She's a
Yeah,
she's a quiet young thing.
but
Uh,
especially quiet.
so, but if you have a question, Campbell, um, type it, and then Alec, you let me know if she's typed something. Okay.
Yes, ma'am. I will.
Okay. All right. I'm just going to start with one, but if you guys have a specific question on the study guide outside of the ones that I'm doing, please let me know. But I just thought I would start with one and go through that, and then just to let everybody know here, Thursday's math lab is going to be in the afternoon because I'm proctoring a mock SAT all day Thursday morning. So I'm not exactly sure. I'm going to kind of take a poll and find out, what's going to end up best for people, even if I do multiple ones on Thursday afternoon. But it won't be in the morning as normal on Thursday. But
Okay.
here we are. On the very first ones, write an equation in slope-intercept form of the line that has the given slope and y-intercept. My opinion, I call these GIFs, but maybe that's just because I'm a math geek. But basically, you can tell the name of the form is slope-intercept form, and you're given the slope and you're given the intercept. So what you're going to do is write y equals, and then you're going to plug in the slope where the m is, and that in this case for number one is 5. Nice 5, Mrs. Sparks. And then you're going to put your x, and then plus, oops, not a, well, you could do plus, but it's not a plus in this particular case. It is actually a minus because the y-intercept is a -2. So there is number one in slope-intercept form with the given slope and the given y-intercept. Basically, all this is testing is, do you really understand what y equals mx plus b is saying? And it's just stating that where the slope is and where the line actually crosses the y-axis. So that's essentially what the slope intercept form is. So for number 2, it would be y equals, and what's the slope there? 1/2. So you would type 1/2 because your slope always needs to be in a fraction form because it's a ratio. It's rise over run. It's the change in y over the change in x. So 1/2 x. And then the y-intercept crosses at 0. So I don't really have to write anything here if I don't want to. I can leave it as is, but if I wanted to put something, I could put plus 0, but it is absolutely unnecessary. So you could leave it like this, or you could add that. I'm not going to count it wrong if you add the 0. That doesn't change anything by adding a 0. But you could, in fact, leave it at y equals 1/2 x. All right. All right. That's those two. Any questions over those two? Does everybody feel pretty good about that?
Yes, ma'am.
Okay, cool. Evan, you're good. Campbell, you're good.
Hold on. Never mind. I'm kind of getting a little bit of feedback.
Okay. Oh, are you? Okay. All right. Is that better? Oh, you know what? It might have been my coffee cup. Sorry.
Oh, no.
Gotta have the Java. All right. This numbers 3, 4, 5. The instructions are write an equation in slope-intercept form of the line that passes through the given point and has the given slope m. So on this particular one, I'm going to use this space right here to do each one individually because this is handled slightly different. There's multiple ways to do this, multiple ways. We could use the point slope form to do this. We could use just the slope intercept form and plug in our x and our y into the slope intercept form. So any of the aforementioned are good. Does anybody have a preference?
Number 5.
Okay,
Oh.
I will definitely do that one, but is there a preference as to the form that you would like me to use?
I kind of like slope intercept.
Okay, so I'm going to stick with slope intercept, and then we'll use the point slope somewhere else. All right, so what I'm going to do is substitute in where there's a y and where there's an x, the ordered pair that's given. So what is my, in number 3, what is my y?
6.
Okay, so 6 equals, and my slope is what?
5.
5. I think you're the group spokesperson because you're the one that I can hear. Maybe Evan's typing his answers, but. And then I'm going to plug in my x right here because here's the slope intercept form. So now I'm on the x. So -1. Okay. Plus b. So now what I'm going to do is just do solve it from here. So 6 equals, and then 5 times -1 is -6 plus b. And now in order to get b all by itself, I'm going to add 6 to both sides. So that gives me 12 equals b. So for this, number 3, I have b. So I'm just going to rewrite it in slope intercept form. So it's going to be y equals, and what was my slope again? 5 x. And now I'm just going to add my b. It's a positive 12. So that's number 3. Any questions?
No, ma'am.
Okay. Did anybody type anything, Alex? Did anybody else join the group? Because when I'm on this page, unfortunately, I can't see who's in the group. Okay. All right. Good. I came back. No questions, Campbell. No questions from Evan. So I'm going to go back and I'm going to do number 4. All right. So once again, I'm just going to use my slope intercept form. And I'm going to plug in my ordered pair that's given here and my slope in the appropriate places. So my y coordinate for this point is 3. So I'm going to plug it in where the y is. 3 equals, and then my slope is a -2. So I would type -2. And then I'm going to put in my x for that. And then plus b, because I don't know what the y-intercept is. That's what I'm solving for. So then 3 equals, and then -2 times 10 is -20 plus b. Now I'm trying to get b all by itself, so I'm going to add 20. Sorry about writing through the other parts, guys. To both sides. So I get 23 here. That's a big y-intercept. Equals b. So now I have everything to write this particular ordered pair with this particular slope into a linear equation in the form of slope intercept. Y equals, and then my slope is what? -2 x, and then my y-intercept is plus 20. Oops, 3. Nice 23 there. Let me remake that. Okay. All right. Any questions on that one? We good? Okay. All right. Hold on. Bear with me for just 1 second, guys. Uh, I'm sorry. I'm checking something. All right. Sorry about that. Okay. Now, I think we're on the one that you really wanted to work on. So, and I think
Yes,
it's
ma'am.
probably because everyone loves fractions so much.
I'd say.
Yeah, I know. Fractions are everybody's favorite. Okay, so basically what we're going to do is just plug in exactly like we've done in the previous ones. We're going to plug in our point, which our y is 1. And then our slope is -3/4. And then our x is -8 plus b. Okay. Now, We're going to multiply 3/4 times a -8. And I'm just going to kind of step to the side over here and do that as a separate step down here so that y'all can see it well. So what I would do is simplify before I multiply. And so what I'm going to do is 4 goes into 4 one time. 4 goes into -8, -2 times. And now what I have left is a -3 times a -2 on the top, which gives me a +6, and a 1 times 1 on the bottom, which is 1. So this is going to give me a +6 plus b. And now in order to get b all by itself, I'm going to subtract 6 from both sides, because whatever I do to one side of an equation, I need to do to the other. So I have a -5 equals b. So that would give me the information to write this in slope-intercept form, which is going to be y equals, and my slope is -3/4 minus, oops, I forgot my x, my apologies, -3/4 x minus 5. That's very messy. Can y'all read it?
Yes, ma'am.
Okay.
Okay.
Evan, I like your comment. Yay, fractions, said no one ever.
It's true.
Yeah, I know. I'm probably the only person in the world that likes fractions. Yeah, they don't bother. I guess when I'm dealing with slope, for like, I don't always like fractions, when I'm doubling recipes or when I'm trying to actually splitting a recipe in half or fourths or something. I like it less then. But for slope, for some reason, it doesn't bother me, because for me, I'm always thinking of it as a ratio in my head. So it translates better. But I'm sure that's only because I'm a geeky math person. But that wasn't too bad. It was nice that the 4 and the 8 would cross cancel, I think. That made that problem a little prettier. All right. My apologies. I need to do something on email real quick.
Who has the bird in the room?
My mother-in-law gave me a cuckoo clock a long time ago, because I grew up with one.
It's 10 o'clock. Yeah.
Yes, it's a cuckoo clock, like from Germany. So
That's awesome.
yeah, I know. I love it. I really do. The bird makes me happy. Sorry. Okay. All right. Everybody got those written down?
Yes, ma'am.
Okay. And no questions so far?
No, ma'am.
Yay. Okay. Now, the instructions for this next part. Write an equation in slope-intercept form, good old slope-intercept form, of the line that passes through the given points. Okay, so the very first thing that we're going to want to do is get our slope. So we're going to use the slope formula. Do you all remember what the slope formula is?
No, not really.
Okay, so y2 minus
Oh,
y1
yeah,
over x2 minus x1. That's the slope formula. And I think what I'm going to do is have y'all make like a note card before the test. And you can use both sides of the note cards and y'all can put the formulas down to use for the
thank you.
year,
Oh yeah, it'd be amazing.
so that y'all can use these. And so maybe we'll even, yeah. Um, I'm going to try to think of, I might make a note card and actually try to post it to Google Classroom to give y'all an idea of what you need to have on there.
Okay, Campbell's gonna leave for a second, but she's just gonna see if it will work. Her microphone. She's trying to
Oh,
fix her microphone.
oh, okay. All right, cool.
She, she's gonna be right back.
Thank you for letting me know. I appreciate it.
Oh, she's back.
Okay. Is it working better?
Are you fixed? Campbell?
Yeah, I can't
I don't think
hear.
it's working.
Oh,
Oh, she's just gonna speak to us, Campbell. Oh, it didn't work. It only made it worse.
oh, well, thank you for trying. If you, like I say, if you have a question, you can type it real quick, or I know some of them are kind of hard to ask, especially if you're talking about fractions or whatever. But Al, and if it's in the middle of the thing, Alec, if you'll just let me know that she's typing a question and that
Yes,
it came up and kind of be our liaison, that would be delightful.
no problem.
Okay. All right. So for this one, we're going to start with number 6. And so the first thing that we're going to do is get our slope. So, and our y's go first. And it doesn't matter which one you start with. What does matter is that you keep it consistent. So if I begin with the second set of ordered pair, like the 5 and the -3, if I start with the y for that ordered pair first on top, I must in fact start with that ordered pair on the bottom. So I would have to begin with the 5 on the bottom if I pick the -3 on the top. That's what's most important, is just making sure that the y2 and the x2 are lined up. If doesn't make it, just the y and the x for a given ordered pair are on top of each other. Does that make sense?
Yes, ma'am.
Okay. So if I want to start, I'm just, since it says y2, I'm going to start with the second set of ordered pair. So I'm putting -3 minus, because that's my minus, and then the y for the other ordered pair is 7. So I'll do that. And then because I started with the -3, I have to start with the 5 on the bottom, the x for that ordered pair. So that's going to be 5 minus a -10. So on the top, I have -10. And on the bottom, I have 5 and a -10.
Oh,
Actually,
Campbell has to leave.
I'm sorry?
Campbell
Evan
has
has,
to leave again.
oh, Campbell has to leave.
Kevin, no, Campbell.
Campbell has to
Campbell.
leave. Does Evan? Is he still?
No,
Okay.
Evan's
Just
still here. We got Evan.
got Evan. We're losing Campbell. Bye, Campbell. Thank you for coming. Okay, so now we have -10
I think she just lost her computer.
over 15. And that actually reduces to -2/3. So the slope for number 6 is, I'm just going to write it right here for just a second, -2/3, just so that I can erase this piece right here. But I've got to remember what it is. Does everybody understand how I got there?
Yes, ma'am.
Okay. These are all things that I would hope that I would see on, when I say, please attach your work. These are the types of things that I'm looking for, because if there's some type of error, I will always give partial credit. Like if there's some kind of mathematical error and you don't get the slope right there, I'm going to look at your process for the remainder of the problem and see that if you're consistently using the slope correctly in the next part of the problem. Because if you miss slope at the beginning, then the rest of the problem is going to be incorrect. But I want to always give partial credit. You know what I'm saying? So if I can see the work, I can give credit. And I'm always going to look for that process to make sure that you understand the process. All right, so now what I would do is pick either one. And we have a fraction. I know y'all are excited. I'm going to pick either one of these points. It doesn't make any difference which point I pick. They're on the same line. So I'm going to pick one of them, though, and I'm going to plug it back in to my slope-intercept form. I could also, once again, I want to remind you, I could use the point-slope form as well for this part. But what I would do is plug in, and I'm just going to pick the first point here. I would plug in my y. 7 equals negative 2/3, because I'm going to use my slope that I just found. And then I'm going to plug in my 10, which is my x value, because I'm using this form right here, plus b. And now, ooh, it's a lovely fraction. Y'all are going to love this. Negative 2/3 times negative 10 over 1. And it doesn't simplify. So it's going to be a positive 20 over 3 plus b. So now, in order to get b all by itself, I have to subtract 20 over 3 from both sides. Are y'all pretty stoked about that?
Yeah. Pumped.
Yes. So in order to do that, I'm going to have to change my whole integer, my 7, into a fraction. Wait a minute. Sorry about that. And then, so what I want to do is 1 goes into 3 times, and 3 times 7 is 21, minus, because this right here is an equivalent fraction to 7 over 1, minus 20 over 3. So that gives me 1/3, because 21 minus 20 is 1. So my final answer there for B is 1/3 equals B. So I'm going to erase some of this. This is all the stuff that I love to see on that extra work page. I'm going to move my slope over here so I don't forget it. So now I've got all of my information to put that into slope-intercept form, and it will be y equals negative 2/3 x plus 1/3, because that was my or my B or my y-intercept. Is it making sense?
Yes, ma'am.
Okay, good. Evan, how you doing?
Good.
Okay. Thank you. All right. Now number 7. So what would I do first?
Oh, Campbell wants me to tell you that she is back.
Yay! Welcome back. There's the answer to number 6. You missed the fraction. Tell her how disappointed she'll be.
Oh, she's been back for a while now.
Oh, did she get to see the fraction?
She got to see the fraction.
Oh, I didn't want her to miss that because I know how you all love them.
Yes, she got to see it, and she's very happy about that. Aren't you, Campbell?
Okay.
Yeah, sure. Is her answer to that.
Okay. Okay, so for number 7, first thing we're going to do is find slope. And so once again, doesn't matter which pair we start with, we just have to make sure that the y on the top is over the same x of the ordered pair is the same. So just so that I can prove that point, I'm going to actually start with the first point this time. And so that is 0. The y is 0. And then minus 2. Because I use this y and this y. And now I got to go back here with a -1 minus 0 equals 0 minus a -2 is a +2. And a -1 minus 0 is a -1. So my slope is, no fraction this time, -2, because I have a positive divided by a negative. But this one thing I want to remind you guys, like what we were talking about yesterday in class, is that with regard, because this is a ratio, this is why when you're graphing something using the slope, you can go in one direction positive and one direction negative, because this -2 over a +1 is exactly the same thing as a +2 over a -1.
I'm going to be leaving in like 2 minutes.
I'm sorry?
And Evan is leaving in 2 minutes.
Okay.
Oh, actually, leaving right now.
Okay. Okay. See you, Evan.
I got to step away from here real quick. I'll be right back.
Okay. Anyway, Evan left. Okay. And Alec is gone for just a minute. Okay. All right. But anyway, Campbell, this is why you can move in negative and positive directions either way, because these two numbers right here are exactly the same. So interpreting this on the graph, if I was using this one, I could go up 2 because my y is on the top and down 1. But if I was using this one, or I mean, not down 1, left 1. But if I was using this one, I would go down 2 and right 1. So as long as one of my directions is positive and one of my directions is negative, that makes it a negative slope. So that's kind of how that works. Okay, so now I have my slope for number 7. And now what I'll do is pick one of the 2 points. And once again, it doesn't matter which of the 2 points that I pick. And I'll plug it back into this y equals mx plus b. So I'm just going to use this first point. 0 is my y. equals, and then I'm going to plug in my slope that I just found, and it's a -2. Oops. Okay, and then I'm going to plug in my y, which is a -1 plus b. And now I'm going to solve for b so that I can get my equation. So I've got 0 equals -2 times -1 is a +2 plus b. And now in order to get b all by itself, I have to subtract 2 from both sides, because whatever I do to one side of an equation, I have to do to the other. So I've got -2 equals b. So now I have my slope, and now I have my y-intercept, so I can give the equation of these 2 points in slope-intercept form, and it would look like this. Y equals, plug in my slope, -2x minus 2. So that's number 7. And once again, I just want to reiterate on that, like the work page, a blank piece of, notebook paper, bring it to class. This is where I'm looking for this type of work. You number them, and that way, if there's any errors along the way, I can certainly give you, credit for knowing the process and walking through the process. And there's a lot of negatives going on. And if there's fractions, I understand that some simple mathematical errors can occur. So I'm just looking for the fact that you know how to do the process. So showing as much work as you possibly can is always beneficial. All right, number 8. So once again, the first thing that we're going to start with is finding our slope, calculating that slope. So we've got our change in y over our change in x. So I'm going to start with the second point and do 13 minus 4 all over 6, because I want this ordered pair should be lined up, one on top of the other. And keeping all of this straight is really, really crucial in making sure you get the right slope. So, and then you'll notice that this ordered pair is lined up, one on top of the other. So 13 minus 4 is 9. And 6 minus 0, or minus 0 is 6. So then this reduces to 3/2. Yay, a fraction. So my slope is m equals 3/2. But remember, it's just a ratio. It is the comparison of the change in y over the change in x. So really, in fraction form is the appropriate way for it to be presented. Now what I'm going to do is take my slope that I just found and use one of my points that's given here and plug in those values into my slope-intercept form. So I'm just going to begin with the first one. So my y is 4. My y value there is 4. My slope that we just found is 3/2. My x here is 0, which technically, to be perfectly honest with you, we should recognize actually this right here and this right here. I went through the process, but I want to point out that if there's a 0 in the x coordinate, that is your y-intercept. Mm-hmm. Does that make sense to everyone? But I wanted to go through the process to make sure you saw that. But if you do see an ordered pair like that, please know that that's what it is. But working through this process is probably a good idea just for the practice itself, if you know what I mean. Y equals, and then we plug in our slope, 3/2 x plus 4. So that's number 8, even though it's not written on number 8's line very well. Okay, so there's 1 through 8. Everybody have those down? Any questions? Oh, hey, Lily.
Hi, Miss Sparks.
How are you?
Good. How are you?
Good. We just got through. When did you join, sweet girl?
Right when you were working number 8.
Okay, right then.
Mhm.
Okay. Did you get to see the whole thing?
No, ma'am.
Okay, you didn't. Okay, so you didn't get to, where did you get to see me work slope?
I don't think so. No.
Okay. Well, 9 and 10 are kind of similar. So we'll be going over that. And if you want to, you could write the answers that I have up on the screen to the side if you want to use them to check later. Can you read my writing? Oh, this writing is. Oh, Alec left. I wonder if he's coming back. Okay, Lily, since your microphone works, Sweet Campbell's voice is very, very soft. So if she has a question and she types it, do you have your chat open?
Yes, ma'am.
Okay, so if she types a question, will you let me know?
Yes, ma'am.
Okay, good. All right, I'm going to go back and start. Okay, I'm going to erase. Oops, no. I'm going to erase this. And start on. Okay, now, number 9 and 10 are much like 6, 7, and 8. In the fact that you can kind of go, oh, you can read the rise over run. You can do that first of all to get your slope, or you can actually use the ordered pair that's there and calculate the slope. You can do one or the other. Does that make sense to you all or no? Like this ordered pair, unfortunately, it's a wonky one, which I'm not super stoked about, but it's 2.5 over here. This, so it's 2.5 to the x coordinate is 2.5 for this one right here, and it's up 2. So that ordered pair is 2.5 and 2. And that ordered pair is 0, 4. But the other thing that you can do is just calculate the rise over run. Okay? That's the other way that you can do. You can count. And is this a positive slope or a negative slope when you look at it?
Positive.
Positive typically goes this way.
Oh yeah, that's a negative slope.
So it and then negative runs that way. So and so because one direction is negative, one direction is positive. So you could actually look at the change in both. So the change is this part because they went down 2. So that's negative 2. And they went right 2.5. So it's almost this ordered pair right here. But just to be on, they went down 2 and they went right positive. So this doesn't go there. Okay, so that would be your slope. Ugly slope. Very ugly. But just to show you that you can do that the other way by subtracting, I'm just going to go through the process of the slope formula. So what I'm going to do is line my y's up. That's 4 from here. minus 2, and then 0 from here, minus 2.5. So that's 2 over a negative 2.5. That's my slope. The good news is, y'all ready for the good news? What, by definition, the y-intercept is where the line crosses the y-axis. And we actually have that given here. Where does it cross the y-axis? Right there. So it's a 4. So the equation for this line is actually y equals 2 over 2.5 x plus 4. Does that make sense? Or not really?
Kind of.
Just kind of? Okay. The y equals mx plus b format, which that's the slope intercept format. This is the slope, the m. Okay?
Mm-hmm.
And this b is the y-intercept. A y-intercept is where a line crosses the y-axis.
Mm-hmm.
Okay, so when you look at this line down here that we're working on number 9, this line crosses the y-axis right here at the point number 4 on the y. So that would be the y-intercept. Does that make sense?
Yes.
Okay, where it crosses. Okay, and the slope, is the slope confusing just because it's a fraction and it has a decimal in it? Is that what's throwing you?
I'm just kind of confused on how did you get the 0 for the 0
The 0 minus the 2.5?
yes, ma'am.
Okay. All right. That's this ordered pair right here. The two ordered pairs given on this graph for number 9 are this one, 0, 4, right there. And this ordered pair right here, which isn't well labeled, but it's up 2, right?
Mm-hmm.
And it's over 2.5. So it's up 2, that's going to be my y, and it's over 2.5.
Mm-hmm.
Okay. So that's my two ordered pairs. So I've got 4 minus 2. That's the two y's, right?
Mm-hmm.
And then I've got 0 minus 2.5
Okay.
because
How
that's
did you get
the
2 for
coordinate.
the y?
I'm sorry?
How did you get 2 for the y for the first equation? For 0, negative 4, how did you get 2?
4 minus 2
Uh-huh.
because I subtract. Where did I get the 2 to subtract it from? Or where did I get this 2?
How did you get the 2?
Right there that I just circled?
Mm-hmm.
Or this 2?
Um, the one on the y. The y.
Oh, right here?
Yes.
Okay. That's the y coordinate of this ordered pair here. Can you see this ordered pair down here? Is it showing up in the
And
Google?
Campbell's asking, wouldn't the slope be negative?
Yes, it is. I've got a negative on the bottom part. Oh, I didn't put it in the equation. That's what you're saying. I'm sorry. You're right. There you go. Yes. I had it up here, but I didn't transfer it to the equation. Good catch, Campbell. The 2 this coordinate right here, that dot on number 9, the coordinates for that ordered pair are 2.5 and 2. So my y for this ordered pair is 4, and my y for this ordered pair is 2. So that's where I got this 2. Does that make sense? Because the top, remember, slope formula, and I wrote this down earlier, is y2 minus y1 over x2 minus x1. So I have both my y's on the top and both my x's on the bottom. And the y and this right here should be one ordered pair. This 0, 4 is this one right here. And this 2.5, 2 is this ordered pair here. So it doesn't matter which ordered pair you begin with. You just have to make sure the ordered pair are on top of each other in the slope formula. Okay? Does that make sense? Or not yet?
I think that makes sense. They just have to be on top of each other. And then you got the 2 from subtracting.
Yes. And I got the 2.5 from subtracting 2.5 from 0. Okay? And then I have that very weird slope. And it does look weird because, you've got it. That's why, and I wish Alec was still with us. That's why it's very important that you state the slope in a fraction format, because it is a ratio or a comparison between two things. So you can't, obviously 2.5, negative 2.5 can be stated in a fraction as well, because that would be, it would be either 2.5 or that, you could state it as 5 over 2, or 3. 5 over 2. So that would be a complex fraction. So that's why that's very important that you understand that slope is the change in y over the change in x. It's that slant. It's how much of a slant that the line is and which direction it goes in. Does it go in a negative direction or does it go in a positive direction? And that's essentially what slope is. This was kind of a complex problem for you to join us on. And I'm hoping, Lily, that as we go over number 10, that, some of this will become clearer, for you as we continue to work through some of the slope process. Once again, on this next one, on number 9, or number 10, I apologize. On number 10, it's kind of neat because it actually goes through the origin. Do you all see that? Where the line is going right through the origin, which that tells me that my y-intercept is going to be what?
0?
Yes, ma'am. Absolutely. It's a 0 because it's going through the origin. So the good news is here, once again, there's 2 ways to find the slope. You can actually calculate by counting the rise over the run because it's a ratio. So how many did we go down there? On this. How many did we go down?
You mean like over?
No, down. Right here, this part. How many did we go down?
0.
Well, when you go from here to here, how many did we go down?
I see. From the 2?
Yes, ma'am. To here.
2.
So we went down 2. And so that would be negative. And then we went right how many? This part. Count over. 1, 2, 3.
3.
Yes. So that's one way by counting rise over run, where you go up or down from one point to the other. So it makes this little triangle. That's what the slope is. Okay? Is this triangle, just like we did over here. We went down 2 and right 2.5. Down 2 and right 3. So that's this one way to do the slope. And then the other way to do the slope is our ordered pair. This is one and this is the other. Okay? Does that, okay? So now we're going to plug those into the slope formula.
Mm-hmm.
So we've got a 2 minus 0 over -3 minus 0. Do you see where I get those numbers?
Yes, ma'am.
Okay. So then you've got 2 over -3 minus 0 is -3. So it's interesting when we calculated the slope this way, my negative was on the bottom, and here my negative was on the top. But it doesn't make any difference because a negative divided by a positive is still a negative, or a positive divided by a negative is still a negative. So that's why you can go up 2 and left 3, or you can go down 2 and right 3. You just have to make sure you're going in one direction negative when you're plotting points. Okay? When you're graphing. Is slope becoming a little clearer for you, Lily?
A little bit, yeah. This just confuses me.
Which part?
Just like finding the slope. Everything else, like solving it's pretty easy, but finding it's harder for me.
It is harder? Which way is easier, counting on the graph or actually doing the equation?
Doing the equation.
It is? Do you just kind of get lost in all the grid?
I think a little bit, yeah.
Yeah. I know. I remember I kind of used to too. And so I kind of defaulted to the formula. But the more you practice, the better and the easier it becomes. So I'm going to erase this. Which one would you rather me erase? You want me to leave this up here?
I think I have them both.
Yeah. Okay.
What would the answer be for number 10?
Okay, I'm going to actually, since we're given the y-intercept, I don't really have to solve anything. So I can just start plugging. So y equals -2/3 x. And I don't have to put anything. I could add +0 if I wanted to, but I don't have to because that doesn't change anything. But my y-intercept for this problem is 0. Okay? Does that make sense?
Yes.
Okay. So that's the answer for that one. Okay.
So could you do y equals -2/3 x plus 0, or would you just leave it?
You, like I said, you could do it, and I'm certainly not going to count it wrong. You know what I mean? If you add +0, if you're trying to let me know that that's the y-intercept, but you don't have to, because obviously adding 0 to anything doesn't really change the value. You know, so you don't have to. Either one is fine. Okay? Okay. All right. And I'm going to try to figure out, Lily, how I can post the math lab so that you could actually see me go through the first 7. Because I did a lot more on the slope and stuff in those. So maybe you could, oh, Campbell, it looked like you had a question and I came back. Oh, wait. Oh. Okay. All right, I'm coming back. I came back to the actual screen where I can see the conversation.
Uh-huh.
And I saw that Campbell had a question. So, sorry. All right, Campbell, do you have anything else before I switch back? Okay, cool. But no, that was a good catch. I just forgot to move it over to the equation. That's what happened on that with the negative. But thanks for letting me know. All right, now number 11 and 12. I know how everyone loves word problems, right? And that besides fractions, it's your favorite. Okay, a delivery service charges a base price for overnight delivery of $15 plus an extra charge of $4 for each pound the package weighs. So we need to write an equation that gives the total cost of shipping a package as a function of the weight of the package. So that means Y is going to equal the cost of shipping the package. And then $4 times the weight of the package. So actually, if I wanted to, I could write this as F of W because it says to write it as a function of the weight. So $4 times W, and then there's a delivery base fee of $15. So there's my delivery base fee right there, $15.
Oh, I have a question.
What? No, go ahead.
For the F of W, Y?
You could do Y. Yes, that's what I wrote at first, and that's fine. You can write that, but it says to write it as a function of the weight. And remember how I've been telling you that F of X is just a fancy Y? Because what you're saying is the function at whatever value the X is, that's the answer. Okay. So what it's saying here, the function of whatever the weight of the package is this whole value, which is really Y. Does that make sense? Or not really?
Yeah.
Okay. So you could write F of W, you could write Y, or you could write C if you wanted to for total cost of the package. It doesn't because all these are just, letters that represent something that's going to make sense to you. So you could write Y, you could write C, you could write F of W. It doesn't make any difference what you write on this side, really. The crucial part is knowing that it's going to be 4 times the weight of the package, however many pounds that would be, plus that flat delivery fee. Make sense? Or not really? Sort of?
Kind of, yeah.
Okay. So what I would write for my answer here, because it asked for a function, I would probably write F of W personally. But if you wrote Y, I would certainly not count it wrong. 4W plus 15. And those are dollars. And now it says find the cost of shipping a 15-pound package. So what I would do is write 4 times 15, and that's my W. So basically, I'm looking at F of 15 equals 4W plus 15. And 4 times 15 is 60, right? Plus 15. So it's $75. So F of 15 The function at 15 is $75.
So you just plugged in 15 to find the total?
Yep. 15 for the weight. I'm sorry?
So you just plugged in 15?
Mm-hmm.
Okay.
And that's this little thing over here, this function at 15, that's just telling you what to plug in.
Mm-hmm.
So you could, once again, like I said, if you wanted it to be a Y, if you wanted it to be C for cost, it doesn't make any difference. But yes, it was asking me the cost of shipping a 15-pound package. So I plugged in 15 pounds for the weight in the equation that I found up here. And and then I, obviously that was so 12 is $75.
Mm-hmm.
Okay?
Yes, I got that.
Okay. All right. Now, number 13, write an equivalent equation in standard form. So all I'm going to do, we did this, trying to remember what, it was either 4.4, I think it was 4.4. Yes, I'm pretty sure it was. An equivalent equation. So what you can do is either multiply the whole thing by something, or you can divide the whole thing by something. And for me, I think I would just go through, and just because I think the easiest thing, what's something that goes into all of these evenly? Into the 4, the 2, and the 16.
2.
Absolutely. So what I would do is divide the whole thing by a -2, just to clean it up, to get the negative off the front and to make it smaller. So I would divide the whole thing by a -2. So -4 divided by -2 is what?
2x.
Is a positive 2x. And -2y divided by -2 is what?
Y.
Good job. And then 16 divided by -2 is what?
-4.
Divided by 2.
Oh. That would just be a -8. Yeah.
Yes, -8. So now what I've done is wrote an equivalent equation in standard form. So you're either multiplying the whole thing by something or dividing the whole thing by something. And that is how simple that one is.
Okay.
That's not bad at all, I don't think. Okay. The next two, we really have to kind of think through. Find the missing coefficient in the equation of the line that passes through the given point. Mm-hmm. So what I would do, the missing coefficient in the first one is A. So what we're going to do is we're going to plug in this given point into the X and the Y. So you would have A times, what's the X in this ordered pair?
6.
So I'm going to put in the 6 minus 4. And what's the Y?
1.
Equals -1. So now I've got A6 or 6A, it doesn't matter how you write that, minus 4 equals -1. And now I'm trying to get this all by itself. So I'm going to add 4 to both sides. That cancels that. And this gives me a +3. Sorry about writing over that other stuff. And then just to make this make more sense, like what we're used to, I'm going to go 6A. Does that make sense? Because this is actually multiplication going on here. And multiplication is associative as well as commutative. So it doesn't really make any difference whether I write A6 or 6A. but I know that you're used to seeing 6a more than you're used to seeing a6. So I'm going to divide both sides of the equation by 6. That leaves me a equals 1/2. So the coefficient a equals 1/2. Okay?
Yes, ma'am.
Does that make sense?
A little bit, yeah.
Could you have done that on your own?
I don't know, because I would have thought to just have added 1 where you subtracted you added the 4.
Yes, ma'am.
I would have added the 1. So how did you, I don't know, confused.
Oh, okay. Because I'm trying to work to get this A6 or this 6A all by itself, I want to move everything away from it and undo it. I'm trying to get this all by itself.
Okay.
So in order to get it all by itself, I have to move things away from it. And isolate so that all of the things that are around it have to move to the other side. And remember, this is the thing where you're doing PEMDAS in reverse. So you have to look, is there some adding and subtracting going on around it? And yes, there was. That's the first thing you have to knock off. And there was. So that's why I knew to add the 4 to both sides. Because you want to get rid of, because if I would have added 1 to both sides, in this case, it would have left me with a 0 over here. Right?
Yeah.
And so I haven't really isolated that A6 yet. Does that make sense?
Yes.
Why I started with that?
Yes, ma'am.
All right. So
B equals 10.
The next one?
Oh,
okay. I don't know. I haven't even worked it yet. I don't even have the answer sheet in front of me. How bad is that? So let me do it real quick. And then we'll take a look at it. I guess I should have had the answer key near me, right? 8 times -5 plus b times 4 equals 4. -40 plus, I'm going to go ahead and change my format to be 4b, 4. And then I'm going to add 40 to both sides. Right? And then I have 4b equals 44. Then I'm going to divide both sides by 4. And I have b equals 11. Is that what you said?
No, I got 10. I didn't add the 4. That's why.
Oh, okay. I can see where you would get that. Yeah. Does that make sense though?
Yes, ma'am.
Okay. Is Campbell still with us?
No, she left a little bit ago.
Oh, she did? Oh, okay. All right. I'm trying to erase all of this stuff in case I have to use this area for something. And I'm going to try to get through, let's see. Let me kind of take a look and see where we need to get to, because you don't have to have this done until Friday. But I definitely want to walk through 16 and 17 with you, since the grid is a little shaky for you. So I definitely want to get those. And then I'm probably going to go through some of this tomorrow in class, so it'll be a second repeat for you. And then I'll have Math Lab again. And something that you missed that was at the beginning of Math Lab was that Math Lab on Thursday is going to be in the afternoon. Are you available?
I should be. What time?
Because I know, don't you sing Thursday night at Town Center?
Yes, ma'am.
What time are y'all leaving for that?
It'll be late, so it'll be like 6 o'clock when we leave. So it should
Oh, okay. So it's probably I'm proctoring a mock SAT on Thursday morning. So I feel like I should get back home by 12 or 1. So I'm thinking it's going to be about 2-ish. Will you be available?
Yes, ma'am.
Okay. So I want to, because I want to make sure that you're there. And if we need to do another Google Hangout like we did the other time, we can. But I'll just keep working today. And if there's something specific at the top that you want me to go back through right now, I can. But let's take a look at 16 and 17. It says we're going to graph the equation using the point and slope. All right, this is actually point slope formula. So let me write the point slope formula right here, just to remind you of what it is. Y minus Y1 equals M, which is your slope, X minus X1. And this second point, or the second number in each of these, is actually your X and your Y coordinate that you can plot. And please notice that the central operation going on here is a minus. So that means down here, when you're pulling the actual point out, if there's a minus, that means the coordinate is positive. Does that make sense?
Where is the coordinate in this?
Okay. The coordinate is, let me erase this circle. Okay. The coordinate is this number and this number in the formula. So it's this number and this number in that particular equation.
Right.
So obviously the X goes with the X. So it's a positive 3 because see, that's a minus and that's a minus. Okay. And the Y is a 2. Does that make sense? How you just pull that point out? That's why this is called point slope, because you're given a point and you're given the slope. So where is the slope in number 16? What is it? Can you tell me?
The slope, or
Yes, ma'am. What's the slope? It's the M.
3x.
Well, it doesn't have to be the X. It just has to be the 3. Do you see that? Okay, so M, it's just, see where this M is before the parenthesis here? See, there's a number before the parenthesis. That's your M.
Yes.
Okay, so it's 3. Okay?
Yes, ma'am.
So now we have an ordered pair and we have a slope. So we actually can create a line. So we're going to go over 3, 1, 2, 1, 2, 3, and then up 2. So there's my point right there. Do you see how to graph that?
Yes.
Okay. So now what I'm going to do is use my slope, which is 3, which really is 3 over 1. And or it can be negative 3 over negative 1, right? That's 2 negatives make a positive. So I can go up 3, 1, 2, 3, and right 1. Or I can go down 3, 1, 2, 3, and left 1. And there's my line. I graphed the equation, and it was given in point slope form. Is that something you feel comfortable doing or still need more practice?
A little bit. I'm still a little confused on it, but.
All right, let's walk through the next one together. All right.
Okay.
Can you tell me what the ordered pair is going to be for this one?
Okay. Um, 1, -1, or no, -1.
Yes. No, you were absolutely right. That was perfect, Lily. You did awesome.
Thank you.
1, -1 is perfect. I'm so proud of you. That is so, so good because being able, what you were able to do is know that that was going to be a 1 based on the formula. And this was going to be a -1 because a -1 would make it a positive. So that is so awesome. I'm so proud of you. Is that how you figured it out?
No.
Oh, it isn't? How did you get it?
I just did what you did on the other one where you just pulled them out.
Okay.
Um,
But so you were able to see that. How did you know the y was negative?
I don't know.
Okay. Well, you did it absolutely correct. So I hope that you can remember how. Okay. All right. Now, this is a little tricky on the slope because there's only a negative outside the parenthesis where the slope is. So what do you think that means? When in algebra, it's real goofy. When there's no number there, what is the understood coefficient?
1,
Yes, ma'am. So what do you think the negative all by itself means? What would the slope be?
-1 or negative.
Yes, perfect. It's -1.
Uh-huh.
That's absolutely correct. You did so awesome. So what I'm going to do is go over 1, down 1, because that's the point that we have, right?
Huh?
That you found. And then I've got a negative slope. So that's either going to be -1 over 1 or 1 over -1. So that means I can go up 1, left 1. Or I can go down 1, right 1. Actually, this is wrong. That would be there.
Uh-huh.
Not there. So there's my line. Oops. I was trying to write C graph. How was that? Tricky or are you good?
A little tricky.
Okay. Well, I've got a couple more like that on another part of this. Okay. This is another exercise in actually pulling out ordered pairs that we have down here, kind of based on some of what we did earlier. It says write an equation for a linear function that has the given values in f of x equals mx plus b. Okay. This part right here, that's the x. So the ordered pair is actually 4, -8, and -3, 1. Is that clear as mud for you or okay?
Clear as mud.
Okay. Remember how I said earlier that a fancy f of x, or this f of x is just a fancy y?
Uh-huh.
Okay. This means the function of x. And remember when we do these xy tables that it can be a function? Okay. And whatever you plug in for x, it has some outcome for y, but x drives the outcome for y. You remember that a little bit or not really?
Not really.
Okay. Well, we'll plug in an x and find a y. So like, okay, we'll say, x at 1, if it was x plus 4 equals y. If we plugged in a 1, then y would be 5, right? So that's why x drives whatever the answer is. X is the independent variable and y is the dependent, because y depends upon what we plug in for x.
Okay.
Okay? So when we say it's a function, what we're saying is that this function at x equals a certain y.
Mm-hmm.
So up here, what this is saying is the function, a given function, when the x is 4, the answer is -8.
Uh-huh.
So that is this same thing down here. What this is saying is the function at 4 equals -8. That's so the function, whatever the function is, and we don't know what it is because we're trying to solve and figure out what it is based on what the answers are. But what it's telling us is whatever that function is right here, when we plug in a 4, we get a -8. But when we plug in a -3, we get a 1. And believe it or not, that's an ordered pair.
Mm-hmm.
So you're looking at this 4, and that's your x, and that -8, that's your y. And over here, that's your x is a -3, and your y is a 1. Does that help or not really?
Still a little bit confused.
Okay.
I thought I was just after you found the 4 and the -8 and the -3 and the 1.
Uh-huh.
I thought I was supposed to solve for slope. So.
You are. I just want to make sure that you're able to get to that part. Like, I want you to understand where I got the ordered pairs. Do you understand where I got the ordered pairs? I guess that's my question.
I think so. Yes, ma'am.
Okay, that's all I was asking. Like, I want to make sure that you're able, like for number 19, that you're able to find the ordered pair. That's what I'm asking. So, but you're absolutely right. The next step in the process would be to find slope. So I'm going to go -8 minus 1 over 4 minus a -3. Do you see where I got that?
I had 1 minus -8 and then -3 minus 4.
Okay, I can do that. It doesn't matter which one you start with as long as you keep them on top. But I can write that.
Okay.
Okay, what did you start with?
Well, I had -1 minus -8.
Where did you get -1?
Oh, no, I'm in a positive one. Sorry.
Okay, all right. 1 minus a -8. That's what you had. So you started with this ordered pair. And then you had -3 minus 4.
Yes, ma'am.
Okay, that's fine. It doesn't matter which one you start with. You just matters that you keep them lined up. Does that make sense?
Uh-huh.
Okay. So 1 minus a -8 is 9. And -3 minus 4 is -7. Is that what you got?
Yes, ma'am.
Okay, that's perfect. Now, what you would do is plug in that 9, -7 back into the y equals mx plus b format, or f of x. So, but you'd have to use one of the ordered pairs. Which ordered pair do you want to use?
-1.
Okay, so 1 equals 9 over -7 times -3 plus b. So then I'm going to have 1 equals -27 over -7, which is really positive, right? Plus B. So now I'm going to subtract 27 over 7 from 1. So that looks like this. Oops. 27 over 7. So I've got to change this 1 over 1 into something that can be subtracted from that. So 1 goes into 7 times, and 7 times 7 is 7. So I'm going to change that to 7 over 7. Does that make sense why I did that?
I'm a little confused.
Okay.
How did you had the y equals 9 over 7x minus 3 plus b?
Okay. Repeat that question, please.
When you got the y equals 9 over 7x and then times 3 plus b. That's where I got confused.
This is the one right here. I used this ordered pair and plugged it back into the formula. So this is the y value is 1, right? So I plugged in the y equals, and then I had to use my slope, which is 9 over negative 7. And then I plugged in my x value for my negative 3 plus b.
But how did you get the... Oh, wait.
I'm sorry?
I was looking at the slope formula and it helped a little bit. But.
Oh, okay. All right. So then I had to multiply 9 times negative 3, which is negative 27. And then negative 7, because this is really over 1. Negative 7 times 1 is negative 7. So that would give me a negative 27 over 7, which is really a positive 27 over 7. And then I have to subtract 27 over 7 from both sides to get b all by itself, right? So that's what I'm doing over here to the side. And so I had to change my integer into a fraction. And I need to have a fraction that has a common denominator in order to subtract. Yes?
Yeah.
So the equivalent of 1, I'm going to write this up here, over 1 with 7 as a denominator is 7 over 7. Yes? Right?
Yeah.
I'm going to erase some of I probably shouldn't have erased that. We weren't really done with it, were we?
It's fine.
Huh?
It's fine.
Okay. All right. So that 7 minus 27 is what? Minus 20 over 7. So that's actually my B. So this is quite a formula. 9 over negative 7. I got to write it over there because I have to erase this. So the formula is technically f of x, which I know that's just your fancy y, so don't let it equals negative 9 over 7 x minus 20 over 7. And that's the answer. It's not a pretty answer, I know. But it's the answer. Do you understand where we got everything?
Yeah, it's just a little hard.
Because of the fractions?
I think so. I think that's what's...
Yeah. I know. I wish it was a little more, when we're learning a concept like that, I wish it was a little more straightforward, but I don't think I have a lot of fractions on the actual test itself. I think I'm going to double check that now that we're walking through this. Okay. Can you give me the ordered pairs for 19?
6, -4, and 9, -9.
Oh, Lily, that's so good. Absolutely. That is absolutely correct. Awesome. I'm so glad that you got that down. That's amazing. Okay, how would you want to set up slope? Which ordered pair do you want to begin with?
Well, my x1, I put 6 and -4. Like 6 is my x1.
Okay, so
x2.
So did you do -9 minus a -4 or the other way?
Yes.
You did it this way?
Uh-huh.
Okay. So yours looks like that, except your 9's probably prettier.
No.
-9 plus 4 gives me a -5
Over 3.
over 3. Good job. So that's what our slope is.
Uh-huh.
And now we're going to plug in to our formula. I think you're doing great. I think you understand way more than you give yourself credit for. We're going to plug in, which ordered pair do you want to use? The first one?
Sure.
Okay. So we're going to plug in a -4 equals -5 thirds times, and I'm just going to go 6 over 1 because I'm just writing that in a fraction. Does that confuse you?
No.
Okay. Plus b. And I'm going to simplify before I multiply with regard to this. So 3 goes into 3 one time. 3 goes into 6 two times. -5 times 2 is -10 plus b. This one's going to be prettier, I think, than our last one. Plus 10. I'm going to add 10 to both sides because I'm trying to get b all by itself, right?
Uh-huh.
And whatever I do to one side of the equation, I have to do to the other. So 6 equals b. So my function for this one is f of x equals, plug in my slope, -5 thirds plus, x plus 6.
That made more sense.
That one made more sense. So it was basically all of the ugly fractions that made the other one worse, right?
Uh-huh.
Okay, cool. Do you want to do one more or do you want to call it quits for the day?
I think, can we do one more if that's okay with you?
Yep, that's fine with me. I don't care. I'm not going anywhere. I thought you were driving. You acted like you wanted to drive. Hold on just a second.